You ever feel like numbers are just everywhere? Well, today we're going to unlock a super simple but really powerful tool that helps us make sense of it all. It all comes down to comparison. And we're going to start with a little puzzle. So, let me ask you something. Is the number 200 big? I mean, is that a lot of money? Is it a long way to travel? A high score in a game? The answer, you'll see, isn't quite as straightforward as it seems. Because here's the thing, a number by itself doesn't really mean much. It only becomes big or small when you compare it to something else. I mean, $200 for a cup of coffee, that's insane. But $200 for a car, that's an incredible deal. See, the number itself is just a number. It's the comparison that gives it meaning. Okay, so if we're going to be comparing things all the time, we need a really solid, reliable way to do it. Just saying one number is bigger than another doesn't always paint the full picture. We need a way to see the actual relationship between them. Let's make this practical. Imagine we're making some juice. As you can see, the more juice we make, the more kiwis and apples we need. The numbers are always changing, right? But is there something consistent? A rule that's always true? Well, we could try comparing with subtraction. But look at that. The difference is all over the place. First it's 1, then 2, then 3. That's not a very stable way to compare. But what happens if we use division? 2 divided by 1 is 2. 4 divided by 2 is 2. 6 divided by 3 is, you guessed it, 2. It is always 2. Now that is a powerful constant relationship. We always need twice as many kiwis as apples. So this super stable, super useful way of comparing things using division, it actually has a name, and it's the key to this whole thing. We call this relationship a ratio. It sounds a little technical, but it's really just a way to write down that relationship, usually with that little colon symbol. For our juice, the ratio of kiwis to apples is 2 to 1. Think of it like the recipe for the relationship itself. And this brings us to a super important point. The order you write the numbers in a ratio matters a lot. A ratio of 5 kiwis to 1 apple is a totally different drink than 1 kiwi to 5 apples, right? The second number is always your base amount. It's what you're comparing against. So, a ratio describes the relationship. But what if we want to boil that relationship down to a single, hard number? Well, that brings us to our next key idea. And that single number is called the proportion. It's simply the value you get when you actually do the division in the ratio. You just divide the number you're comparing by the base amount, and that turns the relationship into one single concrete value. Let's make that crystal clear. If you have a ratio of, say, 3 to 10, the amount you're comparing is 3, and the base amount is 10. You just divide 3 by 10, and you get your proportion, 0.3. Simple as that. Now, a number like 0.3 is useful, for sure, but it's not always the easiest thing for our brains to grab onto. So we came up with a brilliant little upgrade to make comparing things even easier for everybody. And that, of course, is the percentage. A percentage is really just a special kind of proportion, where we agree that the base amount is always 100. This is amazing because it puts everything on the same scale. It creates this universal language for comparison that everyone instantly understands. And getting there is incredibly easy. All you do is take your proportion, in this case, 13 divided by 20, and you multiply it by 100. That's it. You get 65. Just add the percent sign, and you've got your percentage. All right, enough with the theory. We've got our toolkit now, ratio, proportion, and percentage. Let's put them to work and see how they help us figure out some real-world situations. Okay, so imagine you're at a bakery, you see some bread, and the original price is 801. But look at that! Today, it's on sale for only 601. So a little quick math tells you you're saving 201. But to know how good that deal really is, we need to compare the amount you saved to the original price. The ratio of your savings to the original price is 200 to 800. So we divide 200 by 800. That gives us a proportion of 0.25. Multiply that by 100, and boom, it's a 25% discount. See how much clearer that is than just saying 201 off? And this works for absolutely everything. How salty is this water? Well, we have 60 grams of salt in 500 grams of salt water. The ratio is 60 to 500. Divide 60 by 500, you get the proportion 0.12. Multiply by 100, and now we know the salt concentration is exactly 12%. It's the same simple, powerful process every time. So look, if you only remember one thing from all this, make it this. A ratio tells you the true relationship between two things. And a percentage, that's just the universal name we give that relationship so that anyone, anywhere can understand it in a heartbeat. Once you start looking for them, you will see these hidden relationships absolutely everywhere. In store discounts, in recipes, in the news, in sports stats. So my question to you is, what's the first ratio you're going to notice out in your world today? Thanks for joining me.